All right, we'll do that one more time. So, good morning, good evening, good afternoon, everybody. Thank you so much for catching our webinar between GitHub Actions and Shipa. I'm Ravi Lachhman, and with me is Bruno, the CEO here at Shipa. And today we're trying to keep it interactive. If you have any questions, feel free to just type them in the chat or the Q&A box. This webinar is really for everybody on the webinar, and hopefully we can help educate you. And if you have any questions, feel free. But going ahead and getting started. So CI/CD application as code, GitHub Actions, and Shipa better together. But first, let's introduce some of the hosts. Bruno, if you want to introduce yourself.
Yeah. As you can see, my background, the guitars and everything, my goal was to be a musician. I realized I was not good enough for that. I moved into software engineering. I realized I was not good enough with that as well. But now it's too late. So I had an opportunity to work across different organizations. Shipa was my second venture, and prior to that, worked at Oracle, my previous startup, HTBase, and others. And my goal has always been how to work with uncomplicated things, right? We already have a lot on our plates, both on the DevOps side or the developer side. We have so much to learn and do. So how can we make things easier? It's always been what I've been searching for. So that's a little bit about me.
Awesome. And I'm Ravi Lachhman. I'm the field CTO here at Shipa. Long background in software engineering. I've never gotten anything right the first time, so I'm the king of iteration. And trial and error is software. If that's how software is built. If anybody tells you any differently, they haven't built software, right? And so I kind of got told in this Kubernetes thing several years ago. I worked at a few firms like Red Hat, Mesosphere. I kind of went full bore, and it was overly complicated for me. Then I kind of transitioned into the continuous delivery world to help people get their ideas in production. And here I am at Shipa. I'm very excited for the abstractions that we're creating and just simplifying things, right? So a lot of what, stealing both of our thunders at the same time. A lot of what you'll see today is just how to make things uncomplicated when going to Kubernetes or other pieces of infrastructure as a developer. You might be a DevOps engineer, your internal customer, or the development teams, or you might be a developer yourself and just looking to reduce some of that friction. So what are we talking about today? So we're going to be talking about, well, let's go ahead and level set. What exactly is continuous integration and continuous delivery? So we have a good understanding of these particular paradigms. And then going to be talking about this core concept of Shipa is called application as code, or AAC. So as there's IAC with Terraform, Shipa is there to have a very standard, very clean abstraction definition for exactly what is an application. And then I'm going to be handing it over to Bruno to kind of show you the better together story. If you're using GitHub Actions as your CI/CD or your workflow engine, how can you start including Shipa and actually simplifying a lot of those definitions with Shipa? So let's go ahead and dive right in. So CI/CD, what are these particular things, right? So let's first start with just some terminology, right? So continuous integration. The end result of CI is basically having that building or the end result is an artifact, right? And so there's a lot of books out there. The words a line in the sand between CI/CD, or you might say CI/CD in the same nomenclature, right? Like I say Coca-Cola for soda or Kleenex for any sort of tissue, that eponym. But basically it starts with source code, right? And so with source code, machines, unfortunately, like humans, don't understand source code, so you have to get it into some sort of binary format. Let that be your language might have a compilation or build process like Maven or NPM. And then more often than not in 2022, you're using some sort of containerization technology like Docker. That going from source to artifact, which includes all the build and packaging, is the point of continuous integration. Usually the end result of your CI process is publishing an artifact, right? So you're publishing it to Artifactory, or since we're talking about GitHub Actions, being nice to our mighty Microsoft overlords, you might be publishing to Azure, ACR, right? The Azure Container Registry. But that's a good sign. It could be, a snapshot build. It could be something that's a release candidate. It could be something that you're tagging as final or tagging as a hash. But that is the end result, going from source to binary artifact to a registry of your CI process. And so that leads us to the other half of that, right? So like what exactly is continuous delivery or continuous deployment, right? So you might hear CD used a couple of ways, but basically continuous delivery or continuous deployment is going from your artifact to being released in production. And there's a lot of steps in between that, right? So not only that you have the application artifact, right? So let's say you have a Docker image, but also you have all of the particular the tidbits, right? So the instructions. If you're using Kubernetes, that might be in Helm chart, that might be a customized file. You can keep going down that list of templating to actually describe the application and specific instructions to install the application. Going towards confidence building, your CD stack will be orchestrating like, hey, do we need to perform a soak test before we deploy to production? So your CD tools should orchestrate that. You might be leveraging something like GHAS engineering. Well, your CD tools should be helping orchestrate that. All this is running on, let's say, for today, your target deployment infrastructure Kubernetes. These processes will be running in K8s. And then finally, when you're ready to go to production, our friend Canary here, you can be doing if something's running in prod, you'll be looking at possibly a Canary release. If it's the first time, it doesn't matter because there's no traffic. But subsequent releases, be looking at Canary release, and you'll be touching multiple clusters, right? So your production infrastructure is typically bigger than lower environments, and so basically going from artifact to production is your CD stack. Now, a modern CI/CD toolchain, right? And so, what does this actually look like? So for your particular CI/CD toolchain, you could be leveraging a lot of different tools, right? So let's say if you're storing your source code in Git or GitHub, you have to separate your CI and CD, right? But prior to Actions, so I'll get into what Actions did. But you might be using a build tool like Jenkins or Drone. You're storing your configuration information in an S3 bucket or Azure Blob Store. You're pulling things from the container registry, and then you might be using a GetOps engine. If we have plenty of talks on that at Shipa, but if you're using a CD solution, right? So that could be an Argo, a Harness, a Spinnaker type of rendition, and basically orchestrating the deployment, right? And so there's multiple. Each one of these tools has a different configuration. Each one of these tools have different entry and exit points. Each one of these tools are different because they're from different providers, right? And there's not a set way of doing everything from source to, let's say, production. And so as a software engineer, if you look at any modern, GitHub project, there's several folders. Like, there's a .travis folder, there's a .ci folder, there's a these configurations are going along with the project, but there's multiple versions of it and multiple packaging options. Now, taking a look at what GitHub Actions is. So GitHub Actions, on the scene now, right? And so what is GitHub Actions? GitHub Actions is it's meeting you where your source code is, right? So GitHub Actions is the power of GitHub with a workflow engine. So GitHub Actions has been expanding. When it came out a few years ago, GitHub Actions was purely an automation workflow engine. But if you kind of peel back the onion, most CI/CD solutions, especially CD solutions, are just workflow engines with different connectivity points. And so as those features start to grow, as those features start to expand, the power of GitHub Actions is that it's a common syntax, right? And so there's been a huge push by vendors. The example, Shipa is a perfect example of that. We have a GitHub Actions provider that we'll be going through today that you can just consume. That ecosystem's been blowing up. I think there was over 500 actions, if not way over that at this point, from different vendors. So it's allowing you to have a ubiquitous experience from source code to the workflow engine. GitHub Actions, if you've never seen it before, if you just browse around different GitHub project, if you see this .github folder, it's a big indication that the project you're looking at, or your project, if you go to our example, will be leveraging GitHub Actions. And so particularly under the .github/workflows is where your actions will list. They're in your project, right? And so if you're learning how to use actions, this is actually how I learned how to use actions. I just kind of looked at other people's implementation of actions and like, oh, this is how you start to use it. And you just have it in your project. And so it ties very cleanly into your project, first-class integration to any sort of event. Anytime you make a commit in certain folders, this is how ours is set up, the action will be kicked off. And it's also, imagine a very modern, if you take a look at very modern CI/CD stacks, there's this concept of being ephemeral or having ephemeral runners. If you look at a Concourse or Drone, basically what GitHub Actions does, and there's a free tier and all sorts of tiers, but for the most part, as a consumer grade tier, it's perfectly fine for these examples. It's basically spinning up different runners for you to kind of run through your CI process or CD process. And so it spins up infrastructure and it takes it away. And so you as a person don't have to manage that ephemeral infrastructure anymore. So imagine it as a SaaS CI/CD, right? So if you had to install a drone by yourself, you're installing Kubernetes, there's a lot of benefit to using it because GitHub actually, if you're using their SaaS version, packages this neatly for you and runs it all for you. And here's me executing the example, one of the examples that Bruno has produced. And so all that's great, right? So it's where your project is, it's running on GitHub. It's you don't have to worry about infrastructure, but there's one other, everything seems like it's unicorn and rainbows skipping around, but there's one other piece of this, and I call it the feeding problem. And what do you feed the thing, right? Like, this could be with anything. This could be with a GitOps engine like Argo or Flux. This could be for another CI type of tool. The engine is super powerful, right? Like it gives you a very clean interface, very clean, non-managing infrastructure. But what do you give GitHub Actions, right? And let's talk about now we're getting into some of the nuances of how you build your applications and how you define them. But this is where Shipa really comes in to help really cure that feeding problem, right? So depending on what side of the table you're on, and this is where a lot of times you see a split between the DevOps team or platform engineering team and a development team. With all this shifting left as a developer, you must say, hey, I wrote all the code. Why do I have to write hundreds of lines of Helm or Go templating to get it into production? Why don't you do it for me or give me an archetype? But let's get to that right now. So application as code, AAC. This is a very core concept to hear at us at Shipa. I'm going to do a little personification. Sorry, Bruno. I just stuck you as a platform engineer here. But I'll pretend, well, I'm a developer. So like if you were to ask me what my application is, I will tell you that it's our repository, image, and a tag, right? So Acme Inc. service 152. That's it. That is an application to me. That's sensitive. But then when I go talk to my buddy Bruno over here, say, hey Bruno, it's time for us to Kubernetes. I think that's a word. It's time for us to Kubernetes. Bruno's gonna ask you some questions now. He's like, okay, Ravi, where's your CI? Tell me how you built it. Tell me how you're going to go deploy it, because where's your Argo CD configuration? Also, we have to install it, so can you give me a Helm chart? And also, we have a service mesh here, which is Istio. Can you give me the routes and Istio objects? And then also, oh yes, we have an exporter to Prometheus, and you configure that correctly over port 9090. And please prove it to your boss that your sneak results are fine. And then he might breathe under his breath, Ravi's too stupid, he doesn't understand JSON it, stuff like that. And then, and then Bruno's up at night, how do we enforce Ravi from stopping doing things? Let me add something in my config management database. And then finally, him and I both agree that Acme service 152, out of this huge chart, like, yes, that's the application. Because if you kind of like role play, like, hey, what are some of the platform engineering challenges? There's a reason why this is like this, right? Like there's just more to running a platform than just the application, even though as a developer, I'm like, I give you the image, please put it somewhere. There's all these non-functional pieces to a developer, which is extremely functional to the platform engineer. How do you monitor it? How do you provide authentication to the service? How do I as a platform engineer enforce something? Where do all of our logs go? My biggest trouble is connectivity. I suck at networking as an engineer. I openly admit that several times a day. And how do we provide something that I said, please expose this on port 8080? How does that get to the world, right? Is it our Istio guru? Is it our traffic guru? Is it poor Bruno here who has to figure that out? Because he's the one running Kubernetes, right? Like, who has to figure that out? And then how do we tie all that into a pipeline? Because that feeding problem, what it looks like today, if you take a look at any sort of modern firm, is that you have dozens of YAML configurations. Oh, yes, networking configuration. Here we go. Here's Istio YAML. Oh, yes, here's a deployment YAML to kind of feed into Argo. Oh yes, here's a service, or here's how we roll it out in Kubernetes. Like there's just so much that gets shifted left. Where does that expertise go? So you have to keep feeding this beast of a process. Yeah, it's hungry for YAMLs, right? Give them their spaces. Hungry for YAMLs. And so how do you combat that, right? Like for the average engineer. I said the average engineer, like it's confusing for me, right? Like I literally wrote the feature. Why do I have to wrap it in all these configs and give it to you in a certain way? It is the nature of the beast, right? In the name of efficiency and shifting left. But there is another way, right? What if you were able to redefine what an application is? So as a developer, it made common sense. And as from a platform engineer, it makes common sense to your internal customers. And this is where you start talking about what is, an application? And with Shipa, we have kind of a 8-pillar, what is an application? And we'll kind of show what this looks like in practice. But clearly, both of us decided that we agree that an application could be an image, right? Like, hey, both of our lists, it's a particular image, but also, hey, an application is a service endpoint, right? It's an address that you can access your service at. Also, from a Shipa perspective, this concept of frameworks is how we kind of bundle all this stuff together. Like, hey, a framework is the conglomeration of all these facets. And also, it's your team, right? Like, who has access to this application? Is it open to the public? Is it only, an internal application? That's a part of the application. Kind of digging into, what a framework is and what in Shipa, this is application as code. We also define as an application or additionally is, okay, let's get a little more detailed now. So your ingress and egress policies, right? Like, as a developer, I know traffic comes in and traffic goes out, but with Shipa in plain English, you can define that. We can kind of take a look at the demo. How do we have access from a platform user perspective? Where are these images coming from? Is it coming from an internal registry? Is it coming from external registry? Is it coming from both? How do we, so from a core problem that, say, Bruno, the platform engineer, has to solve? Can Ravi's application eat all the cluster limits? Or can we box them into certain pod constraints and resource constraints and replica constraints? And how do we, keep this all secure, right? And so those are things that at Shipa we help define. And that certainly Bruno and I have been without this before, long in our career, having to kind of hand roll a lot of these with my hands. But with that, I'm going to conclude some of the abstract topics I'm talking about here and hand it over to my buddy Bruno to actually show you what does GitHub Actions and Shipa together look like? So, Bruno, I'm going to pass the torch over to you, bud.
Yeah. Thanks for that, Ravi. Let me try sharing my screen. I think you need to make me the host again.
Oh, yeah. Let's see. Click. You've been promoted, sir.
Nice. Thank you. There you go. I believe you can see my screen now at this point.
I can see it. Yeah.
Sounds good. As Ravi mentioned, if you have questions or thoughts, feel free to type them in the chat or send them as a question. We're happy to answer that. And as part of the Ravi's description is, we're going to kind of peel back some of the components, and we're going to show you an option how you can actually build your entire workflow, right? Because GitHub Actions is great. Now, how can you make consumption of it easier? And there's a lot more to it as a platform engineer or DevOps engineer that I want to build to have that complete workflow that I can serve my end users, probably your developers. So a few of the components that we have today here, I have a Shipa Cloud account. I'm going to be using the SaaS version of Shipa, which you can sign up for in the link that I just sent in the chat right now. It's free. You can get started and you can deploy your apps and do everything that we're doing today free of cost. Another part of it I'm going to be using is a Kubernetes cluster. I chose GKE in this case, but you can choose any other supported cluster, AKS, EKS, or DigitalOcean, for example, or Linode, if you want kind of other options. And I'm going to be using a simple repository that I'm going to be kind of breaking down into application definitions and quote unquote infrastructure definitions. You have a sample here as well that you can clone or fork, or you can use it as a reference. So those are the components that I'm going to be using. GitHub Actions with GitHub, Kubernetes on GKE, but you can use others, and Shipa Cloud. So we have Shipa Cloud here. Let's just to reinforce what Ravi mentioned. The first component as a platform engineer that I want to do is I want to be able to connect to multiple clusters so my developers can deploy applications to multiple clusters. And I want to enforce different policies and rules to different applications across different clusters, right? Maybe you have project 1, project 2, and project 3, and they all have different requirements, or you have development, staging, and environment. whatever way you want to do that, you can separate that. And the way we do that separation on Shipa is using the policy frameworks that Ravi just mentioned. What you have in front of you here is my Shipa dashboard. And if I had two frameworks, for example, I'm going to be able to create my frameworks. And the way Shipa connects to these frameworks in the cloud is creating my cluster, right? So if I go and add a framework, for example, I can define policies across resource consumption, RBAC, registry control, and others. And I'm going to be showing how you tie this all to GitHub Actions. So it all becomes one single workflow. And you can create a policy 1, policy 2, development staging, you choose. And you can bind that to one or multiple clusters. So how do we bring this over to GitHub Actions, right? How do we define this from GitHub Actions? As Ravi mentioned, Shipa has an action for GitHub, and that's why you see, let me just make this larger. There you go. And we have the .github folder here, so you can identify that we're using it. I have broken my GitHub repo into the following structure. I have broken down into an infra folder where I'm hosting my infrastructure definitions. So all my policies and where to which cluster these policies should be connected. And we're going to go into that. And the other part I have broken down is my development application and my production application. So I have two apps. You can break down folder, and there's a lot of discussion out there around how to structure kind of your folder and so on. And you can do it in different ways. This one here, I'm assuming I'm the DevOps engineer or the platform engineer, and my developer has gone through the CI process, like Ravi mentioned. You've tested your code, you built the image, and you stored it in Artifactory or Docker Hub or whatever else you're storing your image. And now my code will, or my definitions will pick up those images that the developer and the CI process built and get it deployed using GitHub Actions. So let's dive first into as a DevOps engineer, let's dive first into the infrastructure definitions, right? I have here my framework definition. I have policy framework dev, and I have policy framework production. I've broken into two kind of policies that I want to connect to my clusters. And I have my cluster definition. If I dive into my policy framework for dev, for example, I have a very simplistic view of it here. You can see more details about my policies actually here. Now I sent it to everyone in the chat message. You can see more definitions here, but in my GitHub folder, I have this is a Kubernetes cluster that I'm going to be binding or connecting this policy to. This is how many applications can be deployed using this policy. And here's some basic kind of network policy, right? Every application that deploys using this policy is going to get an allow all for both ingress and egress. You can go into more detail as a platform engineer and say, hey, for my dev policy, for example, I want to make sure that only this team can deploy using this policy. Or this is the level of security scan I want to enforce every time an application is deployed. So no log4j, for example, is allowed into my cluster. Or my developers can only deploy images from docker.io Shipa software using this policy. Anything else, I want Shipa to block it. And as Ravi mentioned, you can see that this is plain English, right? Me as a platform engineer, I don't care if it's what's the API version, if it's GKE or AKS, I'm building my policy in a scalable way. So I have this here. And the other one that I have is my cluster definition, right? My cluster definition, it's pointing to my cluster address in this case. And it's saying, hey, for Shipa to connect to this endpoint or this cluster address, I have this CA cert and this token. And these are the policies that I want to connect to this cluster. One thing to mention is I have my terminal here in front of me. Every policy that you create and you bind or connect to a cluster will become a namespace in your cluster. Right now, my cluster is clean. I don't have Prometheus installed. I don't have Nginx. I don't have nothing, right? So how do I take this cluster from a raw cluster to an application ready cluster? So here we have these definitions. The other definition that I have is my application definition, like Ravi mentioned. If I go into dev app, for example, I have, this is what my developer can see, right? Or my developer can use to deploy the application. And the reason why we've made it this way is because then we as DevOps engineers, we can get out of the business or having to build all these Helm charts, templates, and every time changing and updating it. And every time there's a new service, you create a new template. This is exhausting, right? And we don't need to do that. So we've created that simple application definition that me as a developer, I can quickly create one and say, this is the name of my app. In case I'm part of multiple teams, this is the team that is going to own my app. And this is the policy that I want to use, right? So at this point, I don't care if it's GKE, AKS, whatever version, all the controls, I don't have to worry about it because the policies will pick up and enforce the policies. I'm passing here some environment variables that my application needs to run. Maybe some CNAME where my application should be exposed. And if I want to overwrite, and if I can overwrite the network policies for my application, for example, as it's being deployed. And here again, you see that me as a developer, I don't know if it's Istio, I don't know how to build rules and virtual services and all of that, right? I'm just concerned about this is how I expose my app, plain English, done. And here's my application, which is a bulletin board that I want to get deployed. So this is how I've structured my cluster and my repo, right? Does it make sense? If any questions or any thoughts, feel free to send. Ravi, does it make sense and goes together with what you described before?
Oh yeah, it makes perfect sense. It's like we rehearsed this before, Bruno. Yes, it does.
I know. It's like we talked before, right?
Yeah.
So I have here my GitHub repo. I have the structure here on my Golang, but you can use your terminal, whatever you choose. And I have the same structure here. I just clone the repo, my dev app, and so on. I want this to be together in my action, right? Because you can break your action into different ways. You can have an action just for infrastructure. For example, creating all the policies and binding this policy to a cluster. Then you can have a different action for just deploying the apps. For the sake of simplicity of this demo, we have one action that creates multiple policies. So if we see here inside our GitHub folder, I have create dev policy, which is going to read my framework dev. I have my production, so it's going to create this policy. And then it's going to connect to my cluster, and it's going to deploy both my development app and my production app. And it's reading from my definitions that I have stored in that Git repo. Does that make sense? Is that clear, Ravi, the way you kind of broken it down?
Yeah, that makes sense. Especially if it's like your first action, like this is a great way to learn just how to set up an action. Because like these are really, it shows a couple of key things. You're storing things as secrets. You're using a couple of steps per run. Also, each one thing that I learned, but I didn't know about actions, that every time you do one of those big steps, like deploy dev, deploy prod, another runner will spin up, and so you have it segregated pretty nicely here.
Nice. That's right. And we're using the Shipa action here to be able to do that, which is what you can leverage. And again, we're going to be taking a cluster that I have nothing, no monitoring, no rules, no nothing, no ingress to an application ready and get my application deployed without me having to manage Helm charts for Prometheus and Helm charts for this and Helm charts for that. And every time I scale a cluster, I have to change, or there's a component I have to change. It's a nightmare. I don't know if anyone here loves doing that, but if you do, feel free to say and why, but I don't. I just like it simple. I have too much to do already. So I have this action here. Let's update it to make it proper to our cluster. I have my cluster definition here. I need to tell Shipa what's my endpoint that I should connect to these policies, right? I have this here. if I run Shipa to connect to your cluster, Shipa will need the endpoint, and Shipa needs a service account in that cluster. Now, I'm going to be using my terminal to do that. You can use GitHub Actions itself to create the service account and get the information. I'm going to be using my terminal just to be simpler for this demo. I'm using a simple script to give me the address, give me the token and the certificate. I know I'm exposing this on the internet, but by the time you're able to copy and paste and connect everything, the cluster is gone. So don't even bother. But you can find this script here just for your reference. I have it in a gist. You can find it here as an example. So what this script does is it gets my cluster API address and it creates my service account for Shipa, and it lists the token and the certificate for that account. Awesome. So if I see it here, now I can get my cluster address. And if I plug this into here, great. This is my cluster endpoint. I'm going to be connecting those two frameworks, those two policies. If I come here, I can see the definition called GHA prod and kind of the definition. And the other one is GHA dev, which is my dev definition here. I don't need to make any changes for the purpose of this demo, but I'm just showing that you can connect two or more. Every policy you connect, you're going to see later that it becomes a namespace in your cluster. So every application deployed using this policy will be hosted inside your namespace. The other part that I need to enter so Shipa can connect to my cluster is my certificate and my token. Let me just make it this way so I can copy it. Control, can delete this, enter this. And last one is my token, which my script also listed this here. Does it make sense, Ravi, what I'm doing?
Yeah, it makes perfect sense. You can also store these things in a secret. If anybody did copy and paste, or with their iPhone, they could take a picture and they can do the text. But don't worry, this cluster will be long gone before.
Yeah. So yes, please do not do like I'm doing today. It's like one of those movies. Please do not try this at home, kids. Store these things in a secret or somewhere else safe, and just pass it on when Shipa is connecting. Or create and populate these files. There's so many.
Or a private repo. I'm used to getting these nasty grams by GitHub now that you have a token, you have a certificate, you have something in your. You can disable that. There's like, I forget what they call it, like their scanning tool. Oh God, I'm blanking on it. But
I'm using a private repo. So even though I shared an example, I'm using a private. Great. So what I did is I've updated my cert and my token file and my cluster definition. So if I save this, and let me see if I'm not forgetting anything. I'll just commit this. If the demo gods are with us today, we'll see it working. If not, we'll probably fail miserably live in a call. And then I'll just push. Here are my changes. And I'll push this. It pushed. If I come back into my actions, I can see a GitHub webcast. So my action is starting. So just as a refresher, I'm creating a dev policy. I'm creating a production policy. And for whatever reason, oh, there you go. I'm connecting to a cluster and deploying these two apps, right? Just using a blank ship account and a blank Kubernetes cluster. This is doing it. And what is going to happen is Shipa is creating those policies and it's going to connect to a cluster. When Shipa connects to a cluster, automatically, because you get the dashboard together, you get all the monitoring, all the ingress, and everything that you as a DevOps engineer, you would need to do. This is done for you. So you can focus on policies, governance, and getting your developers to deploy their applications faster. So you look good. That's the goal. Right now it's connecting policies. You're going to see that this process takes about a minute and a half. And this is because it's installing Nginx by default. And it's installing monitoring and it's installing everything. If you already have an Nginx controller, ingress controller, or if you have Istio, for example, you can tell Shipa to just connect to that. And you're going to be able to see how to do this here in the documentation. You can also pass an endpoint and file format and others, so where you can connect to an existing cluster. Right now it's running, it's connecting to the cluster. If we go into my terminal and I do kubectl get namespace, let me see if I can see something already there. Great, so I see 3 new namespaces already. I see one called Shipa. That's where Shipa services, the dashboard, the monitoring, and everything will be populated, deployed. And I have 2 other, right, namespaces. One is the GHA dev, and the other one is the GHA prod namespaces. Again, those are each for each policy. So every application deployed there deploys to those namespaces. If I come in here, it's probably finishing the services and all. If I do kubectl get pods, Shipa, you're going to see the metrics and monitoring and others running. And you see an Nginx controller running. Is it clear, Ravi, what's making sense? Am I missing anything from what I'm doing?
No, that made sense. I mean, just to reiterate, like, just imagine doing this without Shipa. Like, it's so anticlimactic when we do these things. I was just reflecting, like, when I execute it, it takes us a couple of seconds, but there's a lot that you would have to build in the background to get this way. And like with Shipa, it's just anticlimactic. It just works.
Exactly.
Like getting your application out there. You don't have to deal. There's a lot of stuff you're not dealing with. You're not dealing with the ingress. You're not dealing with the egress. You're not dealing with a Helm chart. Helm and I have not a good relationship, and it's like you literally did everything in like a couple of minutes. So I'm impressed with it.
Exactly, and the process is done. So we have both our applications deployed. If we go back into the dashboard, I can see my 2 policies created, and I can edit them later if I need, but you can see kind of your policy definition directly here. You can see your cluster information, my GitHub Actions GKE, for example. I can see my policies are connected there. I can see them listed here. And I can see my 2 apps deployed, right? And if I just go into my production app, directly from here, I can see all my applications details. So we went literally from a raw cluster to both my applications and policies and cluster connected, everything done in just a few minutes, right?
And you didn't have to write any custom. I know this is out of scope for the for this webinar, but you didn't have to write any customized overlays. Like, this was so simple. Like, I just, for folks who know what that is, like, they'll be like, yes, this is much simpler. If you don't have to write one. So
no customize, no Helm charts. Me as a developer, I don't care if it's Kubernetes. Me as a DevOps engineer, I'm defining policies. I don't care about the underlying infrastructure. I'm defining what needs to be done and deployed. And one of the problems we have as you start scaling a bunch of services, and this should be part of your overall workflow, right? A lot of people get hung up on CD. How do you deploy? How do you deploy? How do you deploy? This is great. We've done deployments in a few minutes. We facilitated that process. But if you want to be successful, how do you handle the post-deployment? A lot of people forget about that. And a lot of issues happen after the deployment, right? One of them is, as you start scaling the number of services deployed and the number of developers consuming this platform, is identifying who owns the service. And directly from here, you can see who's the owner, which namespace it's deployed on, and so on. You can see how much resources this is consuming, or if it's unlimited in this case. You can see where this application is being served, any environment variables that were defined for this application. So now your developer, your DevOps team, SRE, and DevSecOps, everyone involved in that process now can get centralized information. As your application starts getting access, you can see kind of how it's performing. You can see everything that happened to your application. So you can see application deployed, application created, and the log associated to this application. You can see any security scans if you enable that were executed and any vulnerabilities were found. You can integrate that directly into your incident management tools, such as Slack, VictorOps, and those are powered by a webhook. So if whatever you use, like Teams, is not here, Ravi wrote a nice blog about it, how you can extend this and add your tools into this process as well. And it can change policies. So now you can really manage your application, not cluster, not kind of all these funky objects that your developers have a hard time. They can see where the application is being served. So Shipa connected into connected to the ingress installed in that cluster and created the endpoint for the application, which you can block if you don't want to expose, or you can only expose to certain services. And directly from here, one of the common problems that we see is a lot of developers, they have a hard time understanding what their application actually becomes. As Ravi mentioned, me as a developer, I'm giving my image, right? I don't care what happens later. But if there are problems, you need to understand everything that image became in your cluster. So directly from here, you can see the image information, you can see pod, unit, ingress. If you have volumes tied to this, you can see it directly from here, and you can see the details as well. So you can really understand if there is a problem, where is the problem, right? And what's the architecture and components of my application? The same way you can see your service to service communication in a very nice map that you can kind of get things and keep moving around and playing with it. But you can see, and this map will get updated as network policies change. So now you have a structured process all the way from CI pipeline integration into CD with GitHub Actions, easy to manage interface, and you can take your cluster from a raw cluster into an application ready cluster, and you can have the entire integrated post deployment management of your application, incident management, integration, observability, application. So now your developers can really own and manage their applications, right? So now you have a complete workflow set up from a DevOps perspective that you can call, now you have an application platform in front of your users to be consumed. That was it on my side. I don't want to take too much time, but I hope that was insightful. Any thoughts, Ravi? Is that right? Did I forget anything?
No, that was awesome. Like I'm just looking if there's any questions on there. I think one last thing that I would leave folks with, I had one slide, was just, we also have an open source project called Catch, or it's like the catch.io. If you're curious about the engine that powers Shipa, we're always looking for contributions and PRs, so don't be afraid to contribute or leverage it. It's a great open source tool out there. So yeah, thanks, Bruno.
Exactly. Let me share Catch GitHub repo. So feel free to visit the GitHub repo. Gives us a star. It is. Support the project, but this is the engine that Shipa uses behind the scenes to kind of create that a standard application definition and then deploy that to your cluster.
Cool. Well, let's see if there was any questions. Didn't look like it. Well, everybody, thank you so much for coming by. Good evening, good morning, good afternoon, or good noon. It's noon Eastern time. I don't know what good lunch. I don't know what they call it if it's noon, but it's. I hope everyone has a great day.
Awesome. Sounds good. Thank you, everyone. Have a good day. Bye.